Yes. So good afternoon to all. Yesterday we start with the system of particle and rotational motion. Already I said in this chapter there is three types. The first one center of mass, second one rotational motion, third one moment of inertia. The first one center of mass it is there now. In this category only we are discussing now. Center of mass, define center of mass. So how to find the center of mass of the particle along a straight line, two particles, three particles, and the xyz coordinate, how to calculate the values and the xyz coordinate, and to find the center of mass of a rigid body having a continued distribution of mass. So up to that we are completed. Now we go for the center of mass. It is related to the motion, how it is changing for velocity, acceleration one by one. So this is also derivation format. Kindly note it. If you have any doubt, you can ask. I will one more time I will explain. Okay. So just to consider one system it is that in this system consists of n number of particle. Consider a system, it have a n number of particle. The mass of the particle m1, m2, m3 up to mn, because I already said that is the n number of particle it is there. The position vector r1 vector, r2 vector, r3 vector up to rn for the position vector. Now my question, uh, center of mass of the system, that the position vector it is or no? The resultant vector formula r vector, I said the position vector capital R vector equal to, what is the formula? You can try, it is possible. Morgan Priya, are you there? What is the answer, ma? The formula R vector equal to M1 R1 vector plus M2 R2 vector plus up to Mn position vector Rn divided by M1 plus M2 plus etc plus Mn. So this is the center of mass of the system, that is the R formula. Now that M1, M2 plus Mn it is there now. I consider to capital M, that is the total mass of the system. Total mass capital M equal to small m1 plus m2 plus up to mn. Just I replace the value, then I will get m r vector equal m1 r1 vector plus m2 r2 vector plus etc plus mn rn vector. This is equation number 1. In equation number 1 it is no, in this equation number 1 I am doing for differentiation for the both side based on the time. So m dr vector divided by dt equal m1 dr1 vector divided by dt plus m2 dr2 vector divided by dt up to mn, it is a constant, drn vector divided by dt. Okay, ma'am. So up to that you can note it. This is equation number 2. Then we go for next page. My voice is audible. It is clear. Today test, how many of you completed, ma? Santosh, you wrote the test. Santosh, Sasivarnan, Vishal, Sri Ramana, Pratibha, Akash, Maniraj. Okay, very good. Ashipa, Maniraj, very good. Others, Abarna, very good. Sanjay. Okay. So everyone attend the test. Okay, it is also important. Then only we can understand which area you feel very difficult. So based on that, I can modify the topics. I can one more time. I will explain. Okay. Now we go for next page. What is velocity formula? Very easy. Velocity.
Distance
Tell me, ma. Your voice not clear to me. Cm. Center of mass. Not for the. So velocity means what? The rate of change of displacement. So velocity v is equal to displacement by time. The displacement Now we consider to the position vector. Then you will get d r vector divided by dt. It is equal to v vector, that is the velocity. Same for the small values also. dr1 vector divided by dt, it is it is equal to small v1 up to vn, like this. dr2 divided by dt equal to v2 vector up to n terms. So all the values I am replacing into equation number 2. Then I will get m v vector equal m1 v1 vector plus m2 v2 vector plus m3 v3 vector plus up to mn vn vector. So this is equation number 3. Based on in this equation, we can calculate the velocity of the center of mass. Okay. For the differentiation, you know very well. One time differentiation means that is the velocity. Two time differentiation means it is the acceleration. Listen, position vector or it is the, I'm doing the one time differentiation dr by dt. So it is the velocity. One more time I'm doing differentiation, that is the dv by dt. It is equal to acceleration for the differentiation method. Same thing I am following here. Already one time differentiation completed. Second time I am differentiation. Capital M dv vector divided by dt m1 dv1 vector divided by dt plus m2 dv2 divided by dt up to vn mn dvn vector divided by dt. Now only I said for the acceleration dv vector divided by dt equal to acceleration capital A. A for acceleration, not for area. Some students still know confused with what is A, what is uh, small a. Okay, based on the question, based on the lesson, we want to understand whether it is area or acceleration. So don't confuse with the acceleration as well as area. Okay, I will mention here acceleration of the center of mass. Center of mass. Same for the small values also. that is the individual particle values. dv1 vector divided by dt, it is equal to a1 vector dv2 divided by dt, it is equal to a2 vector up to vn also now. dvn divided by dt equal to an vector. So all the values I'm applying to in this formula, then you will get that one more relation. Kindly note it up to that.
Sir, show the slide up, sir.
Yes, ma'am. Then you will get m a vector equal to m1 a1 vector plus m2 a2 vector, etc., plus mn an vector. This is equation number 4. Okay. Now, same formula related to force. What is Newton's second law of motion? What is the formula? Anybody tell me? Newton's second law of motion formula. Gokul Ram, Ham version, Maniraj, Navantika, Prabha, Sanjay, Sri Ramana. Otherwise, give me text through the WhatsApp. Sorry, Zoom chat box himself. Nitin, yeah. So Newton's second law of motion formula, F is equal to ma, mass into acceleration. Okay. See in this equation, same only no. That m1 a1 it is no, that is a f1. Then you will get F is equal to F vector equal to F1 vector plus F2 vector plus up to Fn vector. This is equation number 5. So related to force. And one more thing, the force it is then the force F vector it is equal to the force of external ext means external plus the force of internal int, that is the internal force. So due to the internal force, the particle it is cancelled out now. Only it is applicable for external force alone. Then F vector equal to F external force. The system only act as only the external force. So F external force equal to mass into acceleration. This is equation number 6. So up to that, the motion of a center of mass completed. First one velocity, second one acceleration, third one force. All three formula we start from the position vector. R vector formula it is R vector equal to m1 r1 vector plus m2 r2 vector plus up to mn rn vector divided by m1 plus m2 plus m3 plus etc mn. That is the position vector formula. One time differentiation, you will get velocity. One more time differentiation, that is the acceleration. Acceleration into mass equal to force. That's all. Okay. Next topic. The conservation of linear momentum and the velocity of the center of mass of a system. Sir, again repeat, sir. You are saying very fast. Again, I will write. Conservation of linear momentum. What is the momentum formula? Are you ready for board exam? Next month for your annual exam it is there. You want to read all the chapter. Hmm? So everyone do the practice now himself. Individual study plan. Prepare yourself. After the class hours, you can spend 2 to 3 hours for the lesson reading. Conservation of linear momentum and velocity of how many students following individual study plan. In home, I am following individual study plan. CM means center of mass of the system. Okay. So now we'll discuss in this topic the conservation of linear momentum and the velocity of center of mass. Again, I will consider the n number of particle system. The masses of the system m1. I asked one question. Till now, I didn't get reply from your side. The linear momentum formula m1, m2 up to mn. Yes, the linear momentum formula, mass into velocity. Good. So masses m1, m2 up to mn, and the velocity v1, v2 up to vn. So first of all, the linear momentum of the system. So momentum represent p vector equal to m1 v1 vector plus m2 v2 plus up to mn vn vector. So this is considered to equation number 1. What is Newton's second law of motion? Newton's second law of motion. Very fast you want to remember. The force is directly proportional to rate of change of momentum. Yeah, good. Same formula, ma. The force, it is equal to a rate of change of momentum dp by dt. And you know the value of p vector, d by dt m1 v1 plus up to mn vn. Up to that, you can note it. Then we go for next page. Consideration of linear momentum and the velocity of the center of mass. I considered masses m1, m2 up to mn, velocities v1, v2, and I am using the linear momentum formula. Next one, Newton second law of motion. There is no external force act as a system. The external force, it is an F vector for the
Sir,
external. Yes,
sir, one minute show that side. Sir.
yes.
Yes, sir. Thank you, sir.
Okay, ma'am. the external force equal to 0. Then you will get d by dt m1 v1 vector plus m2 v2 vector plus up to mn vn vector equal to 0. Okay. So finally, it is equal to 0 now. Then differentiation equal to constant m1 v1 plus m2 v2 etc. plus mn vn equal to 0, not a 0, equal to constant. This is second equation. So based on in this equation, you can understand the law of conservation of linear momentum. The no external force act as a system, then the total linear momentum of the system remaining constant. For in this all equation, I consider to capital M, capital V, vector equal to constant. In below you can write now law of conservation of linear momentum. Okay. So now RDA is a system of particle. There is three track. One is the center of mass. Second one rotational motion. Third one moment of inertia. So now we completed center of mass. So tomorrow class onwards we will discuss the rotational motion, how it is related to in our day-to life. So it is important also rotational motion and moment of inertia. In these two track important. So this is also important only no? But that is a very important. For competitive exam, more than two questions will come in this chapter. And a related problem also we will discuss one by one.